In this video, I will take you on a mysterious journey inside a black hole. You will learn many fascinating things about black holes that will blow your mind. I will discuss here what are black holes from their birth to death. Can black holes give birth to new universes, or are they portal to another universes? How many types of black holes are there? What will happen if you fall into a black hole? How scientists find these invisible black holes in space? And what happens to the matter that has fallen into it? The video also covers the concepts of white holes, black hole information paradox, loop quantum gravity, the possibility of singularity inside a black hole, and lot more. So, I would say you should watch the video till the end to understand the mystery of black holes in detail. So, let's first understand what is a black hole. A black hole is a region of space-time having gravity so strong that it swallows anything that comes close to it. Nothing can escape from a black hole, not even the light. Therefore, we cannot see them as it absorbs all the light falling onto it. So, we call them black holes. Now, I will explain how black holes are formed and how they die. A black hole can be formed by the death of a massive star. When the thermonuclear fuel of a massive star has exhausted at the end of its life, its core starts to collapse inward upon itself due to its own gravitational pull. The outer layers of the star are blown away with an explosion, and the core continues to contract to the maximum limit possible until its density reaches almost up to infinity. To give you an idea about how much matter a black hole can contain inside a small space, let me tell you, if our Earth gets compressed to form a black hole, it would convert into a ball having just 1.7 centimeters of diameter. But what do you think? Will the black holes live forever in space or die ultimately? Actually, nothing in this universe lasts forever, and black holes are not any exception. The quantum field theory in curved space-time predicts that black holes emit Hawking radiation. Hawking radiation is the thermal radiation that is predicted to be emitted by black holes spontaneously. Black holes keep losing their mass as energy via Hawking radiation and would disappear ultimately. But the death process of a black hole because of Hawking radiation would take unimaginable time to complete. According to estimates, a supermassive black hole would take nearly 10 to the power of 100 years to shed all of its mass via Hawking radiation to disappear completely. Now, I will discuss, can black holes create new universes, or are they portal to another universes? According to the Smolin's hypothesis of cosmological natural selection, which is also known as the Fecund universes theory, published in 1992, a new universe is emerged on the other side of a collapsing black hole. This newly created universe may have slightly different fundamental constant parameters from the universe where the black hole collapsed. For instance, in this new universe, mass and charge of the elementary particles may be slightly different, or the value of the universal gravitational constant may be different. So, the Fecund universes theory says that each universe can generate many other universes, and the number of universes a universe can create is equal to the number of black holes present in it, as each black hole present in a universe has the potential to give birth to a new universe. Scientists have classified black holes into three types based on their sizes: stellar black holes, supermassive black holes, and intermediate mass black holes. Stellar black holes have mass approximately equal to 10 times the mass of our Sun, while the intermediate mass black holes can be thousands of times more massive than the Sun. But the supermassive black holes are really huge. These gigantic black holes are millions or even billions of times more massive as compared to our Sun. Interestingly, almost all the galaxies have a supermassive black hole present at their centers. The supermassive black hole that lies at the center of our own galaxy, the Milky Way, is known as the Sagittarius A star. This supermassive black hole is 4.3 million times more massive than our Sun. It is thought that supermassive black holes are formed by absorbing other stars and merging with other black holes. What would happen if you fall into a black hole? Due to extremely high mass of a black hole, the fabric of space-time around it gets curved heavily. This curved space-time near a black hole not only lengthens the distance a beam of light has to travel, it also slows down the time, as it is a space-time fabric, not just the space fabric. This effect is known as the gravitational time dilation. Therefore, if any object or you fall into a black hole, you will appear to slow down for an observer far from the black hole as you approach the black hole. For this observer, you would almost seem to stop when you reach to the event horizon of the black hole because of slowing down of time infinitely. So, for him, you would never seem to fall into the black hole. Actually, as you reach to the event horizon, you will not be seen by the observer who is far from the gravitational influence of the black hole, because no information, including the light reflecting from your body, can reach to the observer when you have crossed the event horizon. Please note that this all happens from the frame of reference of an outside observer, far from the black hole. But for the object falling into the black hole, time seems to pass at the normal speed, and this process takes less than a second. Friends, as we know, nothing can escape a black hole, not even the light. So it's impossible to see them directly. Then how our scientists find them in space? Scientists have not only found many black holes in space, but also have taken their photographs using Event Horizon Telescope. Event Horizon Telescope is an array that links together 8 existing radio observatories across the Earth. Hence, it forms a virtual telescope equal to the size of the Earth. Although black holes cannot be seen directly, but it's still possible to detect them with the help of different indirect techniques. Actually, when a black hole swallows matter, an external accretion disk is created due to friction heating that forms quasars. Quasars are the brightest objects in the universe. Stars, before being swallowed by a supermassive black hole, are shredded into streamers that shine with great intensity. So, the presence of accretion disk and quasars can be detected by the scientists around the black hole. It has been estimated that there are around hundreds of millions of black holes in the Milky Way galaxy alone. Black holes can also be of different types based on their spin and charge. There are black holes that neither rotate nor have any charge. These are the simplest static black holes. Others are both rotating and charged. There are another kind of black holes that are non-rotating but have charge, and non-charged rotating black holes also exist in the universe. Now, let's discuss about the weird properties of the black holes. The no-hair theorem postulates that once a black hole gets a stable condition after formation, it has only three independent physical properties, which are its mass, angular momentum, and electric charge. Apart from these properties, the black hole is featureless. So, according to the no-hair theorem, any two black holes having same mass, electric charge, and angular momentum are indistinguishable from one another. It happens because after falling of an object into a black hole, all the information associated with the object about its shape or distribution of charge on it is evenly distributed along the horizon of the black hole. Hence, this information is lost completely for an outside observer. This is famously known as the black hole information loss paradox. But what happens to the swallowed matter inside the black hole is still a mystery. According to the predictions of classical general theory of relativity, the center of the black hole is a gravitational singularity. Singularity is a place where the space-time curvature becomes infinite and matter is compressed down to infinity to a tiny point. At singularity, the laws of physics don't work. Even the concepts of space and time break at this point. All the mass of the black hole is considered to be concentrated at its gravitational singularity. For a black hole that does not rotate, the singularity is in the form of a single point. But for a rotating black hole, this central region is smeared out and forms a ring singularity. This ring singularity lies in the plane of rotation of the black hole. But in both the cases, this singular region has zero volume. But these predictions are not realistic as the concept of singularity neglects the quantum effects. So, a quantum theory of gravity is needed. Loop quantum gravity is a theory that extends general relativity by quantizing space-time. This theory predicts that black holes evolve into white holes. According to the loop quantum gravity, fundamental building blocks of space-time are in the form of extremely small loops, and these loops have finite size. When a star having mass many times more than that of our Sun has exhausted the internal thermonuclear fuels in its core, it starts to collapse under its strong gravitational pull. But according to the theory of loop quantum gravity, the compression of the star cannot reach to the point of singularity. That is, the point of infinite density. The theory predicts before reaching the point of singularity, the star experiences a quantum bounce. It exerts outward pressure on the star, and this black hole converts into a white hole. The properties of a white hole are just opposite to that of a black hole. A white hole is a cosmic object that spits everything out and nothing can enter into it from outside. You will be surprised to know that this process of transformation of a black hole into a white hole takes only fractions of a second. But for the observers outside, far from the black hole, this conversion process would seem to take billions of years. Actually, this happens because of the time dilation inside the black hole. The extremely high mass of the black hole distorts the fabric of space-time, so time moves at slower rate near a black hole. But at the center of the black hole, the time almost freezes. So any process that happens in fractions of a second inside the black hole seems to take billions of years to complete for the outside observers. Therefore, in the process of transformation of a black hole into a white hole, we will see a black hole for billions of years. As our universe is only 13.8 billion years old, we are able to see only the black holes. It may take many more billions of years before we can actually see a white hole when this transformation process completes. Hence, loop quantum gravity theory explains how white holes are formed from the black holes, and why haven't we been able to discover a white hole yet. With the help of this theory, we can say all the black holes that we are seeing in our universe now will turn into white holes eventually. So, if you want to see white holes, you need to wait for billions of years. According to a paper published in 2012, Big Bang itself was a white hole. Researchers say that Big Bang was actually a supermassive white hole that created our universe. The whole matter that was swallowed by the supermassive black hole was released by the supermassive white hole, and hence our universe came into existence. Some researchers think that a white hole may simply be the opposite end of the black hole. These two ends are connected through a theoretical tunnel of space-time known as the wormhole. This tunnel is also called as the Einstein-Rosen bridge. All the matter and energy sucked into the black hole will be finally ejected out through the other end of the black hole, which acts as a white hole. Here, you need to know that a wormhole is a shortcut through space and time. They are the special solutions to the equations of theory of general relativity by Einstein. Wormholes connect two distant points in space or time through a tunnel. Although white holes have not been found so far, but mathematically, possibility of existence of white holes is equal to that of the black holes. Some solutions of the equations of general theory of relativity predicted black holes before they were actually discovered. In the same way, other solutions of these equations also predict the possibility of white holes. With the existence of white holes, it is also possible to solve the black hole information paradox. As we know that information can never be destroyed, but all the information contained in the object falling into the black hole is lost. This concept of loss of information in the black hole creates the information paradox. But the loop quantum gravity theory can solve the information paradox very easily. As per this theory, the information is not lost in the black hole. It simply gets transferred to the white hole. So the black hole information paradox doesn't arise here. So guys, this was all about the black holes, white holes, and different theories associated with them. Friends, if you found the video informative and interesting, then please like, share, and subscribe. Thank you for watching the video till the end.